appropriated for public and private purposes. So this is our system of water right. It's based on person-time, person right to protect investment in development of that water resource. It basically charges the chief engineer to set up a system of allocating the water and then a system of dividing up the water in times of shortage. And it's based on the Western doctrine of prior appropriation, as I've talked about. So we've had the system in place since 1945. Things went along pretty well. We had a couple developments that happened sort of in the 50s and 60s, 40s. We had some very significant improvements to pump technology that allowed us to access groundwater in ways that we couldn't before that time. And then in 1947, someone in Nebraska invented the center pivot, which opened up vast areas that were previously not available for irrigation use to be open. And as a result of that, this is basically a depiction of the points of divergence that are authorized on water rights in Kansas. And most of the early development was along our streams and water courses, both surface water and the associated alluvial groundwater use. But with the development of that pump technology and center pivots, we opened up very significant areas in the Oglala Aquifer in particular, and overdeveloped that resource, as we all know about. This is just a depiction of how we use water, where we use water, sort of the quantities. Each county is represented, the size of the circle. The bigger the circle, the more water that's used. And then the color depicts the purpose. So in eastern Kansas, the dominant use is municipal. That's sort of the orangish kind of color. Yellow is industrial. Most of the quantities are driven by power generation. And then as you go in eastern or western Kansas, then the blue is irrigation, which is the dominant use out west. And so as a result of that large-scale development for irrigation, we're seeing water level declines. The governor went through this map yesterday, so I won't, but it's basically showing a fairly crude estimate of remaining usable life in the aquifer. And really, there's two things I want, as I talk about this, that I want you to see. And number one, there's areas we're done, there's areas we're close to done, there's areas that have a lot of use remaining 100 years or more. So there's a lot of variability. So as we look for solutions, there isn't one solution that we can just apply that makes sense. Okay, we've got to come up with solutions that sort of match the problem.